G'day legends, I hope you're all fantastic. On today's video, I am chatting to the amazing Santiago Alvarez. Again, we're going to be talking about modulation effects, and we're going to be looking at the key differences and similarities between chorusing, flanging, and phasing. I'm going to play you a very quick example to get started where we're going to hear a chorus, flanger, and phaser side by side. I want to know in the comments, like, which is which? Can you pick them out, or do you have absolutely no idea? So I'll play you the example, and then hopefully the discussion we have will help you fine-tune your ears so that you can pick out which effect is which, and in doing so, give yourself the power to choose between the various options for whatever musical setting you're in. Let's hear it, and then let's chat. Time-based modulation effects. So we're talking about chorus, flanger, phaser. How are they similar to one another? How are they different to one another? And how do you make one? Because the giveaway is time-based, right? So if there's anything common between all of these, what would you say it is? And then what are the main differences between them? Maybe we start with a chorus, because that's, I'm sure most people know what a chorus does.
Yeah, I mean, the common thing on all of them is they play with the delay of the signal, okay? With the timing from where you play, when you play it, to when you hear it in relation to the original signal, okay?
Okay.
Because if I am playing guitar and you see me, you cannot detect a delay of 10 milliseconds, okay? I mean, you will see me strumming, you hear it, you don't know anything, or 50 milliseconds. But if I'm playing it, I feel it as a latency. You know, the usual, you plug into a computer interface and it's horrible because you have to wait to hear yourself.
Oh, I know that one well.
Yeah, everybody knows that one. So you can use those problems to your advantage. Okay, as usual, there is always. So you can play with the delay of the signal and combine it with the original signal to do choruses, flangers, phasers, delays. Okay, so before going to the chorus, let's start with the delay.
Yes.
Okay, which is the easiest to understand. So as long as the time from when you play to when the signal comes back is long enough, say 50 milliseconds, just random-ish value, okay, you will hear it double. You will hear from my slap back, you know, like to very short echoes to, I don't know, 40-something seconds. That's some rock effects.
Yeah. Just in case you want 40 seconds of delay.
Yeah, you know, nobody knows why. But anyway, so that's a delay. Everybody understands a delay. You go and play and you hear it. Now, imagine you make the delay shorter, say 30 milliseconds, 20, 30 milliseconds, okay? So that starts combining with your signal and starts probably sounding a bit metallic in a way, for the way of both signals are combining. Just imagine you have your guitar and just slightly delay the same signal, okay? And will be some tiny peaks and valleys that will cancel and some peak and valley that will reinforce, okay? But if the trick here is modulation, so if you move the delay, the time of the delay signal is coming back to you back and forth, you know. So say you are on 30, as we say, we're in 25 and 35, you know. So you starts getting the filtering of both signals starts being different, and the human being perceives that as a chorus. Okay.
Right.
And it's a chorus because it's what we do when we sing or when we play violin or guitar, because we want to be in tune, and it's so difficult to be perfectly in tune just by playing a flat note. So you do the vibrato with the voice or with the guitar, violin. So the human brain is smart enough to go for the fundamental, to the right note.
Yeah. It's almost like you create a neighborhood around the note, right? Where it's like it's somewhere in here. Your brain can figure it out.
Exactly. And if you imagine we are 10 people, we all sing, you sing along and we're all out of tune, But when we sing all together, we sound huge, because this is what's happening. You are doing maybe some vibrato. I am a bit over-tuned. Your friend there is off-tuned by lower, but everything together goes into a chorus. And this is something that you can do with a detune, the detune effects in a pitch shifting, or when you play 4 guitars, different guitars, you put them together in the mix, they reinforce. It's like using one guitar and a chorus in a very blunt way. Okay, so if you remove the original signal, you will hear the vibrato. Actually, that's how vibrato effects work. It's a chorus without the direct signal. So you just have the module. You hear it as a pitch up and down. Okay, so you hear like moving the string up and down in the guitar.
And I guess the origins of something like that, like as you said, chorusing, and we'll get onto flanging in a second, but you would get a similar effect from, say, like the mechanical instability of, say, a tape playback machine, right?
Yeah.
That would be a similar thing, a warble, I guess, as people would call it, if it had a low frequency.
As long as you have a wobble and a variation in frequency, but not by itself. Okay, you need to combine it with something else, because by itself you will hear it like an ambulance coming and going. So you need to combine it with itself, and then reinforce it or cancel. You hear it as this chorus, as this reinforcement that we are talking, like a choir. Okay. That's the voice is called chorus ensemble. Okay,
that's where it came from, right? And I guess the Yamaha call it like symphonic. That was their particular chorus, and I know a few other rack things. They always have like an ensemble effect, which I guess is probably a multi-voice chorus. So it's interesting.
Like a Dimension C, for example, or some multi-voice, as you say, chorus. They just have, instead of one signal being delayed, they have multiple signal delays in different timing. You modulate them and it gets huge, bigger and bigger. So that's how a chorus works. Okay.
So how do you make one with an electronic circuit? That's my question.
Yeah. Okay. There are 2 basic ways. Okay. The easy to understand is digital. So you sample your signal, you store it in a memory, and you take it out some milliseconds later. That's your delay. I mean, you are sampling it, you put it in a memory, and you take it out on real time. Okay, so it comes and goes all the time. So if you modulate you put them at a fixed rate into the memory, and then you take them out on a modulated rate. Okay, so you are, again, that's why you have your delay being modified with the clock, with the modulation signal. So that's how you do it in a digital way, which is how many of the chorus are doing now, racks, multiflex, and so on. In the past, they were analog, like the Bosch and all the stuff for the analog chorus. The way they did it is using a chip that is called a bucket brigade device. Okay.
So this is when you see BBD.
BBD, the famous BBDs, I don't know, from the late 70s, early 80s, or whenever they came. And the way they behave is they're called bucket brigade because you have to imagine, I don't know, let's imagine 512 firemen, in line, and then your signal comes. Your signal is a bucket of water, so you pour the bucket of water to the first fireman, and then you clap. That's your clock, and then everybody pours their water into the next fireman. Okay. So you have your signal being sampled in analog because you are not converting it to digital. So you have different levels of signal being chopped and passed in buckets down the line. And then at the end of the line comes your signal delay. So that's how an analog delay, analog chorus is working. So again, you modulate the clock that the fireman passes the water to the next one, and then you have this whoosh whoosh of the modulation of the chorus.
I find it funny that last time, you used the bicycle analogy when talking about things like Class A and bias, that the analogy they would have been using to understand these, that's what it ended up with, like a bucket brigade. That's actually in the name for the chip.
That's the description of the chip, BBD, bucket brigade device. And there is no need to think more. This is what is happening.
This is what happens.
There are actually two lines in parallel because you have to pass the water to the guy. You cannot pass the water to the next one. He has to empty his first, right? So there is two interleaved lines. So you pass to the bottom one, and you have to always empty your water into an empty bucket.
Right. So my question quickly with that is, now that BBD chips are hard to source and there's very particular ones, what do the chips have a particular sound, or is it that they have a particular set of qualities that you need to work around, so you need analog circuitry to deal with their shortcomings, and that's what gives, say, a classic chorus or flanger or delay its sound?
It's a bit of everything. As you can imagine, if you imagine the 512 or 1024 for a delay, or 64 or whatever, it's very lossy. Just imagine the water being spilled all over. You cannot 100% pass all your water from a bucket to the next one without losses. So that's happening there. That's happening inside those chips. And then at the end, the signal is not continuous. You're putting your guitar signal, which is an analog continuous signal, and you have some sort of chopped signal at the end, lossy, because you have loss of the water you are wasting when dumping the buckets. Then you have the clock is feeding through, because you are hearing the claps also at the end of the BBD. So you have to filter that, and also you have to do a lot of analog trickery to remove the noise.
Right.
So you have to pre-filter the signal, so you don't have the famous aliasing. So the signal and the clock don't mess up, because actually we're talking about very low frequencies in these BBDs relative to the audio. And there are some tricks like doing compression and expansion.
So this is the famous compander in these circuits?
The compander. Yep. So because the signal to noise on these chips is so bad, that so imagine you have a very faint signal, it will be noise inside the bucket. You cannot pass that little amount of water to the next one, because it's so small that it evaporates.
Yep.
So you have to artificially boost the low signals and compress the high signals, so the amount of water is more or less constant, that you pass. And then at the end, you have to do the reverse operation.
Right.
So you can start doing pre-emphasis and de-emphasis. So the highs get boosted, then you do compression and expansion, then you do filtering, then you put in the BBD, and then you do all the reverse steps. So it gets difficult to get a hi-fi or a professional, very clear analog delay. There were some Yamaha E1010 or E1020, something. I have one somewhere that they use the same chips, but they get much shorter delays. The shorter delay, the more fidelity you have for the signal.
Right.
The slower, just imagine, you have the bucket, you pass, you wait, it evaporates.
You lose signal. It's funny though that, because, and now I don't know if this is because they were used on classic recordings and sounds that they're considered like that, or because all the filtering actually ends up being quite musical. these get associated as being warm sounding, and that's quite desirable now, right? Even though from a technical perspective, there's so much loss.
They first of all, they add distortion. So at the end of the BBD, you have distortion that was not, that signal that was not, you have a harmonics of the signal at the output, and then you are filtering. So that's what a warm overdrive is, again, a very fast and simple way. You just distort the signal and you filter it down, all the crap, all the fizz on top. So they add that. I mean, you try to remove it later with all the filters and stuff, but of course, it's not as transparent and as crisp as a digital delay or a digital conversion.
Yeah. So my understanding is with early digital delays, or so-called DDLs, digital delay lines, a lot of that compression, expansion, and de-emphasis filters were still used. As opposed to a modern DSP-based delay where you just use a high-quality, analog to digital converter. You do it all in DSP, and then you just pop it back out, and it can be super hi-fi. And
the thing is that back in when the first digital delays came, what was that? The Roland SDE. What was the first one? The 2000.
The 2000 was first, right?
Yeah, and then 3000, then 1000, and then 2500 or something. Anyway, I mean, there was some Cork and etc. I mean, the analog to digital conversion, the chips didn't exist. They were really poor. So it was all done by hand. So that's when Boss came with the 12-bit, AD conversion in the Boss DD3. That was like, it's done really by hand,
Right.
It's the converter done like, okay, I have my transistor here with my capacitor, I sample, I then compare to my 12 bits of levels, I find the right one, and I put in a memory. So that's how the very old delays were done, which now it's the same, but this one chip that gives you 24 bits with dynamic range of 120 dBs, and you don't have to worry about anything. I mean, it's the resolution of the converters now is bigger than their signal already.
Yeah. It's interesting thinking about the fact that it is, thinking in that context, it's an engineering solution to a problem, right? It's not magical analog versus, evil digital or something like that. It's just they're solutions that evolved over time. And, you could see from like tape-based delays to, the analog style delays to the early digital delays to the more modern digital delays, there's a pretty clear evolutionary path. So circling back around, we've got, you can create echoes and you can create really short echoes and you can modulate them. With a chorus, there's the way that it sounds wobbly and out of tune sometimes. Is that because there's a perceivable difference between the delay and the original signal in that 30-ish millisecond range?
Yeah, I mean, obviously the longer the delay, the more detune you will hear. And again, you can try very easily, just get a delay pedal and just move the delay up and down.
Yep.
I mean, you know how it sounds, right? I mean, it's like a vibrato bar. Yeah, you just get a huge pitch shift up and down. If you go to this 30 milliseconds or whatever, you start hearing it as a vibrato, which is a slight amount of pitch. If you lower it down, you will not really hear that anymore. You start hearing a flanger, okay?
Okay.
Which is pretty much the same. I mean, if you see a schematic of a flanger of a chorus, they are pretty much the same, okay? Maybe they have a shorter BBD or a shorter delay in the digital, but the rest is pretty much the same. The thing is that when the signal is short enough and you compare it to the original signal, some heavy filtering starts to happen. Okay, it's what's called a comb filter because it looks like a comb.
Yep.
So it has notches. So depending on the relation of the delay of the original signal and the delay signal, the notches are in different places. And you hear it original, a very metallic sound. which is, again, this is what happens when people complain that my effects loop doesn't work. Okay.
Yeah. I remember that as trying out rack effects with.
Yes.
I think it was on a Marshall TSL with the parallel loop, and going, why does it
Crap
sound
loop.
like I've got a flanger or a phaser or something like that on there?
Yeah, it sounds weird. It sounds some metallic, like two metal plates clapping each other. It sounds nasty in a way. So that's what happens when the signal are so close together. I mean, the delay is so short that some parts will really combine, some parts will really eliminate. It's not that if you have a long delay, it's impossible because the signal is different over time. So even the note is the same, the signal is slightly different. Okay. If it's so short, you are comparing the signal to itself, just slightly off. I mean, just imagine you compare to itself at the same time. We'll add 2 times, okay?
Yep.
If one is out of phase, it will be 0. So you have a notch there. A notch means 0, and when they combine properly, you have a double the output, okay? So that will be different depending on the frequency because you are delaying a fixed time, and the frequency is obviously different number of cycles on the same time. So I mean, you asked me before some sort of analogy, and the thing that came to my mind was the stroboscopic effect in the Western movies. When you see the coaches and you see the wheels that sometimes they seem to be stopped, sometimes you see no radios in the wheel and so on. I mean, that's somehow what is happening in a flanger.
Right.
Okay. So because you are changing the delay, you're changing the relative timing of the wheel versus the film. Okay.
Yep.
So you see very slowly moving up and down, then very fast moving up and down. I mean, that's a stroboscopic effect. But that's how some frequencies get reinforced. So you see it stopped, or some frequencies get canceled. You don't see the wheel anymore. Okay.
I really like that. Like the bicycle analogy last time. I find that's a really easy one to understand. You can also, I mean, with flangers to get the swoosh, right? Obviously you've got that kind of comb filtering effect in there.
Yeah.
You're then sweeping the delay, so
I mean, you can try, actually. You can do a very blunt flanger. Just get a parametric EQ. You put a very high Q, the quality factor. Just put a very, very narrow, then put it to 0, to off. So you have your notch.
Yep.
Then just move the frequency up and down, and you will hear the crappy flanger happening.
Yeah.
You'll hear it. You'll hear this. That's a flanger. So if you do it in a proper way musically, you combine it with the original signal, and then you get the flanger. Then a difference between some or most of the chorus and a flanger is the flanger usually have the feedback.
Okay, right. Yep, of course.
Yeah.
And you can change the phase of that feedback, right, as well. That'll give you different character.
That's how you play with the comb. Okay, right. You can make more notches in the comb. You can make less notches. You can make them a bit wider or a bit narrower. You can, if you invert the phase where was canceling, now it's reinforcing. So
I see.
That's what you do with the phase. In a chorus, you could change the phase or so on, but this delay is so long already that probably you will not hear much.
Right.
Unless you go to a very short chorus delays. Because again, the brain cannot already tell the difference of the phase.
So that leads us now. There's obviously the similarities between a chorus and a flanger will be it's a short delay. The flanger's very, very short. So you get the comb filtering effect, and you can add feedback, and you can change the phase of the feedback in there. But you kind of end up with like these harmonic notches in there, right?
Yes.
the similar effect you might hear from something like a phaser. And anyone who's played, think of Ain't Talking About Love, that's a phaser,
Okay.
and think of Unchained, that's a flanger. One's like more swooshy and metallic and another's smoother.
I mean, in a nutshell, it's the same of a flanger, but the notches of the comb are in different places.
Right.
Okay, because in the flanger, you get your signal, you delay it all the time, the same amount of delay. Okay, your 3 milliseconds, your 7 milliseconds, whatever, is fixed. So it doesn't matter if you're playing a low E or a high 24 E on the guitar, it gets delayed 7 milliseconds. Okay,
right.
So the whole signal is just shifted or backwards, depending on what you look at. But anyway, the signal is delayed as a chunk altogether. But in a phaser, the amount of delay depends on which note you are playing. So
I see.
Maybe the low E is not delayed at all. Maybe the G on the 12th string, third string, 12th fret is delayed exactly to be out of phase with the original G you're playing, and then the next G is maybe in phase. Okay.
I see.
And the way you do this is what is called all-pass filter. Okay, that's the technical term of a circuit that does this sort of effect. It's a filter that passes everything. It's flat, so it's not really a filter, but the phase depends on the frequency.
I see.
Okay.
That so if you looked at a particular note, for example, in isolation, and it didn't have any overtones or anything, ignore that, you'd see the same amplitude and frequency come out, but the phase relationship has changed.
Yes. So if you check the original note and the one after the all-pass filter, the phase will be different depending on the original frequency. Okay, so now the trick, and this is the thing, is that this filter doesn't have enough phase shift. So that's why you have phasers with phase 90. Okay, it's 90 degrees of phase. So you get your signal 90 degrees out of phase or whatever. You start putting more stages, like 2, 4. So you get the number of times the signal is changed the phase is bigger, higher. So you get more notches.
Right.
So that's why some phasers, Van Halen phaser is very simple. Then you can go to like the Boss pedal had a switch for certain amount of number of phase shifts. So depending on how many phase shifts you have different amount of notches.
With a flanger, the notches are going to be quite predictable, right? Because of the delay relationship. Whereas with a phaser, you can make the notches like non-harmonically related.
I mean, they're all predictable in a way that it's all mathematical. Okay.
The
phase shift is, but in the phase, usually they have this control that, I mean, Boss call it manual. That is the one that offsets which frequencies you want.
Okay, right.
Okay, so you depend on when you set that control, you set, okay, my G and the 12th fret third string will be out of phase, and then you move that up and down. Or you can say, no, I want my B on the third string, fourth fret. So you move the notch, the phase center down. So, but the where the notches will be, that depends on the number of phase shifts.
I see. Okay.
So you're moving the comb. It will be a comb with the how you call the spikes. I don't know how you call it in the comb. So it will be at different distances or same distances. I mean, and you move the whole thing up and down.
Right, and that's your
and then
swooshy
you start
phaser.
modulating.
Yeah. I
by
see.
modulation.
So it's totally understandable that all of these modulation effects you could mistake for one another, and you can get them to kind of sound. You could make a flanger sound kind of like a phaser, or sound like a typical
Well,
chorus effect.
I mean, you need to train. Okay, it's like everything. You need to train your ear. But the thing is that it's true when you get to a very resonant effect, you put a lot of feedback. It starts getting more and more confusing of which one is which. I mean, in general, the flanger sounds metallic. The phaser sounds soft.
Right.
To say two words, okay. But it's again, it's a comb filtering with different notches. So I understand why some people cannot tell one from each other.
Yeah. I think when I started out playing as well, it was they're all just things that went swoosh, and I'm fortunate where I've been able to, especially the last couple of years, where I thought I didn't like flanges for a long time, and then I played some good ones, and you sort of go, oh, some of my favorite records. I thought it was a chorus sound, but it's actually a flanger. That extra little bit of like swoosh on there, or the really short delays, you start being able to discern.
That's, I mean, also at the other extreme of you cannot tell a flanger from a chorus. If you take a flanger, you put the delay the longest you have, you remove the feedback, and you put a bit of modulation. People will tell you that's a chorus because it's a chorus.
Yeah, because I mean, isn't it the Boss? I think I was reading the Boss CE1. Yeah. Its delay time is actually around 5 milliseconds or something. It's actually quite flanger-esque.
I'm saying numbers here. The numbers are just ballpark. Okay.
Yeah.
The flangers are very short delays. The chorus are medium delays that you don't hear as a slapback, and then delay you start hearing from a slapback to long delays. So it's a continuous thing. It's not that 10 milliseconds is flanger, 11 milliseconds is chorus. No, I mean
yeah. It's semantic at the end of the day with those, isn't it?
Yeah, it is.
But the way you build a phaser that's a distinctly different implementation.
It's a different animal. It's a different family. It's a different. I mean, the principle is the same. You play with the time of the signal in relation to the original signal, but the way you are delaying the signal is different.
Yeah.
So again, a phase is a delay because you take the same signal and you just put it up later. So the signal comes out of phase with what you put in, but you're not storing it somewhere and then taking it out.
Right. I see.
So that's. I mean, if you think about it, that's why an all-pass filter will have different phase with different frequencies, because the output is really depending on the input. It's something that is happening. A delay, as a flanger, a delay is you store it. You just make a picture and then you put it there, and then you don't touch it. It's photocopy of your original signal. So it's not something that is happening more alive,
Yeah. It's and at the end of the day, a lot of it kind of comes down to taste. And there's obviously a whole bunch of other, you mentioned earlier, you have detuners, which use a different method of doing that. The other classic modulation effect is a rotary speaker, right, where you make use of the Doppler effect.
Yeah, and a phaser also.
Yeah.
It's a Doppler effect and phaser together. And actually, the flanger. I mean, you know how the original flangers came down? It's having two tapes, and you touch the flange of the reel. Okay, so you delay it. And if you think about it, you're delaying everything the same time.
Yep.
You're taking, because it's the same music coming late. So that's like you store it and then you put it back a bit later. So that's where the name came from.
It's interesting, isn't it?
Phaser is like the Doppler effect. The rotary speaker is you put a rotary speaker and then you hear the signal and the reflections in the room that come very near to the original signal, but out of phase, because the phase relationship is being changed. But if the room is good, you are not going to filter the signal. So that's the phasing thing. And actually, you can do a phase, and you can hear the phase effect. If you play music on your phone, and then you just move your phone back and
Yes,
forth,
of course.
That's phasing. Okay,
Yep.
that's what's happening. I mean, it's a Doppler effect, is whatever, but at the end, it's the phasing of the. Or you just turn it, like 90 degrees, like 180 degrees, like this. That's phasing that you're hearing.
Mate, again, thank you so much for this education in all the fun things about guitar effects that we like. We will do this again soon. And I'll say to everybody watching, please go and check out the podcast episode we did with Santiago, because we talked all about the glorious distortion generating machines that he was involved in designing. So, mate, thank you so much. I'll see you very soon, and we'll all see you all very soon again.
Thanks. Thank you. See you soon.
And I should put answers at the end of this, right? So the clip that you heard, the order went flanger, phaser, and chorus. After the examples in the video, you could probably hear the flanger at the start has that kind of metallic swoosh about it, this thing. Whereas the phaser has a very similar thing. All these effects have the same rate on them, but it's just smoother sounding. It's like silky to the ears. And then finally, the chorus effect on there sounded totally different. There's a much longer bass delay time on this chorus. It's about 20 milliseconds versus the flanger, which was going from about 1 to 10 milliseconds. Let's hear the flanger and then the chorus. That to me sounds a bit thicker. I would use the analogy of it sounding syrupy to my ears. You can definitely hear that detune effect in there that you couldn't really hear with the flanger or the phaser. So again, a massive thank you to Santiago for having a chat. Let me know what you would like to hear in future videos, and I'll let me know what's your preference: chorus, phaser, flanger, rotary speaker, uni vibe, none at all. I'd love to know. Thanks for watching, and I'll see you next time.